In this video, let us speak about transition metals today. Now, where are the transition metals located in the modern periodic table? As the name suggests, transition metals are in that region of the periodic table that is found while transiting from the S-block metals towards the P-block. As also mentioned in the name itself, these elements are metals, that is, they are hard, lustrous, and good conductors of heat and electricity. They have high melting and boiling points. So, how would we define transition metals? According to IUPAC, transition metals are those elements that have a partly filled d subshell. They can give rise to a cation with an incomplete subshell. Usually, the elements of groups 3 to 11 are called transition elements. They form paramagnetic compounds due to the presence of unpaired electrons in d subshells. For example, iron in the +2 oxidation state has 4 unpaired electrons in the 3d orbitals. Do you know that transition metals can form a large range of complex ions in various oxidation states, and they usually form colored compounds? For example, cobalt chloride is red, potassium dichromate is orange, nickel sulfate is turquoise, and potassium permanganate is purple. Now, both transition metals as well as their cation can act as a catalyst. Next are the d-block elements, present from group 3 to group 12 of the long form of the periodic table. One of the most important things to keep in mind is that all transition metals are d-block elements, but all d-block elements are not transition metals. The group 12 elements, that is, Zn, Cd, and Hg, have a full-filled outer d subshell configuration. Thus, they are d-block elements, but not transition metals. These d-block elements are classified into different series, depending on which d subshell the last electron enters. The d-block elements are further divided into 3d series, 4d series, 5d series, and 6d series. Let us have a look at the electronic configuration of the d-block elements. The general outer electronic configuration of the d-block elements is n-1, d1, to 10 ns, 0 to 2. Let us now list out the 3d series elements. The 3d elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. All these elements have filled 4's subshell. The number of d electrons increases from left to right. However, do we see any exceptions? Yes, we see exceptional cases for chromium and copper, because the preferred and observed half-filled and full-filled electronic configuration of chromium and copper, respectively, gives them more stability. The 4d transition series elements are yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. We can observe the same exceptional pattern for molybdenum and silver. The other elements which show exceptions are niobium, ruthenium, rhodium, and palladium. The 5d transition metals are lanthanum, and then from hafnium till mercury. We can observe the exceptions in cases of platinum and Au or gold. Why do transition metals show variable oxidation states? The transition metals form compounds in many oxidation states due to low energy gaps between the n-1d and ns shells. For example, vanadium shows all possible oxidation states between 0 and +5. Do you know? Along with the d-block elements, there are lanthanides and actinides present in the F block of the modern periodic table, which are called inner transition metals. Finally, we can conclude that We learned not just about transition metals but also D-block metals in this video.